Okay, this is part 2 of the third example problem, 3.6, which involves throwing a stone off the top of a building. Just a quick review. We actually found the initial components here of the velocity. We also found the time here. I already circled it once, but here and over here. They're the same time. The first way we did it, we used y equals VIYT plus 1/2 GT squared, which is using the quadratic equation. We solved for 0. We named A, B, and C. We found a time of 4.22 seconds. In the second way, we actually didn't use the quadratic equation. We found the final velocity at the bottom when it hit the ground in the y direction, and then we solved for the time using VFY equals VIY plus GT, which is right here. I'm going to erase everything now. The last thing we need to solve in this problem is for the range. And once again, just like all the other problems, the range, once you find the time of flight, seems to be the easiest thing to find. So I'm going to add here to my initial velocities the things that I've solved for. I have a time of 4.22 seconds, and I have a VFY equaling negative 31.4 meters per second. Okay, so let's go ahead and solve for the range. Remember that the range is the x. So x is equal to VIXT. X then will be equal to positive 17.3 meters per second times the total time of flight. And my final x value is going to be positive. And it is 73.0 meters from the edge of the building. That actually finishes example 3.6. The one thing that we haven't done in any of the example problems so far is actually solve for the final velocity. Okay. The final velocity is over here, and it's the velocity in the angle that it actually strikes the ground. And we've done enough so far to actually solve for that. So I'm going to add a part C. VF. You notice I don't have any VFY or VFI. It's just VF. What's the final velocity? Okay, so for part C, let's write down what we know. We know that the initial velocity in the x direction is plus 17.3 meters per second. We also know that that is equal to the final velocity in the x direction because there's no acceleration. We assume that there's no air. Secondly, we happened to find VFY earlier when we were solving for the time the second way, and it was negative 31.4 meters per second. So my final velocity over here actually is made up of two vectors. Here, which is v f x and also here going straight down, which is, can't get it in there, VFY. I'm going to redraw that over here. So I have VFX and I have VFY. So I'm going to solve for both the magnitude and direction. If you take a look at this, we have a right triangle. Okay, we can use the Pythagorean theorem. Remember, a squared plus b squared equals c squared. So I will have vf squared equals vf x squared having a little bit of an issue here with the board. So we have vf squared equals vfx squared plus vfy squared. When we plug, vf is equal to the square root of vfx, which is 17.3 meters per second. You have to square that, plus negative 31.4 squared the answer to that, I'm going to get out my calculator. Is 35.9 meters per second. Okay, now that's our magnitude. It does not tell us the direction. The last thing we need to do is solve for our theta. And so we have here, this is our theta right here. The tangent of theta would be equal to VFY over VFX, the opposite over the adjacent. So theta is equal to the inverse tangent of negative 31.4 divided by 17.3 . And that would give me an angle of negative 61.1 degrees. So these two combined, the magnitude and the direction, actually give you the velocity at which it strikes the ground. The difficult thing here is that if you do use the quadratic equation, you will actually not have this VF right here. So you would have to know to solve for the VFY before you do this. And also the negative 61.1 degrees here, that's okay with me to leave it like that as long as you set your triangle up like this. Because our coordinate system to the right is 0 degrees. So if we go negative 61 down like this, that's perfectly fine with me. Okay. You could possibly say it's also 61.1 degrees with the east and west kind of direction there, but that's not necessary in this case. The negative 61.1 is good enough. Okay. That's part 2 of example 3.5, which I consider to be the most difficult problem.